Hi everyone. Uh, we are going to solve the midterm questions today. Can you hear me? Okay. I'm going to solve the questions. If you want to know any further information, please write on the board, and I'm going to check there also. Okay. Let's start with the first one. Okay, it is the really simple one that we encounter in the exam. Uh, Assume that we have three different consumers, and they have a demand for the eagle shirts. And again, in the market, we have two different suppliers. One of them is the black shirts factory, and the other one is the white shirts factory. And we know the inverse demand functions of Metin, Ali, and Feyyaz. These parts are the inverse demand functions. And we also know that supply functions of the factories. This one for the black shirt factory and this one for the white shirts factory. Let's check the questions. In the first section, in the A section, it asks us that find the aggregate demand function and draw it on a graph. For the second part, find the aggregate supply function and draw it again. Let's start with the A section. Let's start. Okay, what we know the inverse demand function of the three different consumers. I take these equations from the questions itself. And first of all, we have to find the demand functions. We have to turn the inverse of them. And for the first consumer, since this part is the inverse demand function, I know that demand function should be 10 minus p divided by 2, this part. But you should also check for the prices. If the price is 0, if the prices is higher than the 10, if this part is higher than the 10, then what happens? The demand will be negative. But we do not want some kind of things in our function, in our graph, so that we can assume that when the prices is higher than the 10, when the prices is higher than the 10, then we have zero demand for the first consumers. You need to do this to draw a proper graph. And let's check the second consumers. We know that this is the inverse demand function of the second consumers. Again, we need to find out the demand equation for second consumer. And this part is the demand equation. What I did, I just make a simple math and leave alone to this part, and then I find out this equation. And again, we need to check for the prices. If the price is higher than the 15, then what happens? Demand will be negative, but we do not want this kind of thing. Therefore, when the prices is higher than the 15, demand should be 0 for the second consumer. Again, do the same thing for the third consumer. And this is our inverse demand function. Let's leave alone the demand side and find out that demand equation is 5 minus p. But check again for the price. If the price is higher than the 5, if the price is 6, for example, then our demand will be minus 1. But again, it is not the case. Therefore, when the price is higher than the 5, demand should be 0 again. So you have to do this kind of calculation for the A part of the question. And then as a second step, let's find out the aggregate demand. Since we know the demand equations for the different price levels, we can easily find out and calculate the aggregate demand. We know that when the prices is lower than the 5, all of these consumers have a positive demand, right? So for find out the aggregate demand, uh, we should add them up. We should add the all the demand function, and we should say that this is the case when the price is between 0 and 5. If the price is higher than the 5, we should consider again the case and find out new demand equation. So, if the price is higher than the 5 and equal and less than the 10, what happens? Check from this part, If the price is higher than the 5, demand for the third person is 0, right? So we do not have to add this demand equation into the aggregate demand function. But again, check when the price is higher than the 5, we have positive demand for the second and the first consumers. So aggregate demand equation is constituted with first demand equation and the second demand equation. Okay, but we are not have the third one because it is 0 when the price higher than the 5. So let's check the prices when the price is higher than the 10 and equal and less than the 15. What happens? Let's check from here. Again, if the price is higher than the 10, we have 0 demand for the third person. If the price is higher than the 10, okay, I'm sorry. If the price is higher than the 10, again, we have 0 demand for the first consumer. Then the only demand that we have to consider is the demand of the second consumer. Therefore, I just take these equations, this one, and show that this is our aggregate demand when the price higher than the 10. Okay? So, as you can understand easily, when the price is higher than the 15, there isn't any demand in the market for this kind of shares. Because check again, when the price higher than 15, the second consumers also have 0 demand, so we have nothing to deal with. Okay, you should do these steps. I categorize the aggregate demand with respect to price levels, and then as a step 3, let's draw aggregate demand function. I know that the aggregate demand when the price is lower than the 5 is equal to summation of the 3 different demand equations. It means that if I add them these 3 to each other, I will find out that the demand should be 40 minus 7p divided by 2. When the price higher than the 5 and equal and lower than the 10, then the demand equation should be summation of the first 2 demand function of the consumers. So this is 35 minus 5p divided by 2. So I just add these two. And if the demand is if the price is between the 10 and 15, then our only demand will be equal to demand function of the second person. And this is equal to 30 minus 2p. And I know that if the price is higher than the 15, we have 0 demand for this market, for the t-shirts market. Let's try to draw this graph. We should draw this graph step by step. And first of all, I write the price on the this axis, this vertical axis, and the demand to the quantity of the demanded on the x-axis. And I know that we have some important price level. For example, I know that when the price is higher than 5, our aggregate demand function will be changed. Again, we have the same uh, situation for the price level 10 and price level 15. Therefore, I just try to write them, show them on the y-axis, first of all. And then I try to find out the proper level that encounter with the x-axis. For example, when the demand is zero, when the demand is zero and price is 15, what happens? I'm sorry, when the price is 15, what happened to the demand? I know that when the price is higher than 15, the demand is zero. So this part is zero, as you can see. When when the price is higher than 15, demand is zero. What happens when the price is 10? Okay, which level is this? This encounter with this equation. If the price is 10, then this part will be 25, right? Um, so demand should be equal to 10. This part should be equal to 10. If I plug the 10 to this equation, I will find out that demand should be equal to 10. Let's plug the 5. Okay, I know that uh, when the price is 5, it is encountered at this price level, right? So I have to check this equation. When the price is 5, this part is be 17.5, I guess. And then this demand level, this level should be equal to 22.5 as a quantity. And if the price is zero, what happens? Let's check this part. If the price is zero, then this level, this part should be zero, and 40 minus zero should be 40. Therefore, our graph, our aggregate demands graph, will be encountered with the x-axis on the level 40. So I just find out the important point first of all, and then I just draw this line between these important points. So that's all. And you can also find out the slope of the graphs for the different level of the aggregate function. In this part, slope is the 0.5. Obviously, it is a negative version of that because this part is 5, this length is 5, and this length is 10. Since 5 divided by 10 equal to 0.5, this is our slope. In this part, we have 5 in this length, for this length, and 12.5 for this length. So our slope is 0.4. If you do the same calculation for calculate this slope, you will find out that it is 0.3. So I just used the simple math to find out the slope. You don't have to do this, but I I want to calculate these slopes to show that the change in the overall graph. Okay. Is there any question for this part? I think probably you did uh, you did the question also in the exam, so this is the simple one. Okay, let's go on. For the B section of the same question, we need to find out the aggregate supply functions. Okay, aggregate supply. Saad asks something about the questions. Is it necessary to find the slopes? No, Saad, you don't have to find out the slope. It is just additional information for you. I mean, it shows that how the graph is exactly changing. It shows just that. So for the exam, you don't have to do this. If you show these calculations, show uh, these levels, these price levels and aggregate demand function, and if you apply this information into the graph properly, that's all for your exam. So let's going on with supply function. We have two different supply function. One of them is the black search factory. It is -4 plus 2p. And for the white shirt factor, we have -5 plus p, this part. So we have to do the same calculation for the supply function. We need to check for the price level. Recognize that for the black shirt factory, when the price is higher than the 2, what happened? Let's assume that the price is 3. This price should be 6. I'm sorry, when the prices is lower than 2, let's assume that it is 1, what happened? This part should be negative. Then, since any supplier want to produce negative amount, it is not possible, it is not the case. Therefore, when the price is higher than the 2, this is our function. But when the prices is lower than the 2, then we have zero supply in the market. Okay? Do the same calculation for the white shirt factory. When the prices is higher than the 5, this is okay. This gives us a positive supply. But when the prices is lower than the 5, for example, if the price is 4, then we have a negative supply. Therefore, for the price level higher than the 5, the supply should be equal to 0. Okay? I did the same thing that I did previous part of the question. Let's check the aggregate supply. Uh, Again, we have different price level. First of all, you need to find out important price level. I know that 0 is important, 2 is important as a price level, and 5 is important as a price level. When the prices is lower than 2, I know from this part uh, our our supply for the black factory is 0, and again supply for the white factory is again 0. So aggregate supply should be 0 when the price is lower than the 2. When the price is equal and higher than the 2 and lower than the 5, then recognize that for the white factory we again have 0 supply. We are not positive supply, but we have positive supply for the black shirt factory. Therefore, we are going to use this equation, minus 4 plus 2p. So this is minus 4 plus 2p. And for the last part, when the prices is higher than the 5, both factories will be willing to supply some shirts for the market. Therefore, we have to add these two equations to each other and find out that aggregate supply is minus 9 plus 3. I just sum the first two supply function and find out this supply, this aggregate supply. Is it clear how did I derive this information? I just find out the price level and check the quantity supply for that price level, and then I find out the aggregate supply function. That's all. Let's draw again. Again, you can use the same logic. We know that price is on the y-axis and the quantity of supply is on the x-axis. I know that the 0, 2, and 5 is important as a price level because we know that there is a cleavage on the graph for these specific price levels. Let's start with the price level which is lower than the 2. We know that when the price is lower than the 2, demand, supply should be 0. I know this information from this part. So as you can see here, our quantity of supply is 0 when the price level lower than the 2. But what happens when the price is equal to 5 for this level? Check from the graph. I need to use this information, this equation to find out the supply because when the price is equal to 5 or higher than the 5, this equation is the true one. So plug the 5 into this equation. This part will be 15. 15 minus 9 should be equal to 6. So it's going to equal to 6 as a supply, quantity of supply, when the price is equal to 5. And again, check for the 10, for example, to draw the graph. When the price is 10, it is higher than the 5. So we can again use this graph. When the price is 10, this part should be 30. 30 minus 9 should be equal to 21. So I find out that the supply should be equal to 21 when the price is equal to 10. I find out the important point first of all. If I just unit them, just draw this line between these important points, you will find out the aggregate supply function. Again, you can find out the slope and show how the slope is changing. It gives some information to you, but you don't have to do this for your exam. This is just the additional information for you. So is it clear? You understand, I guess, how we find out the aggregate supply function. So I move on with the C section. Okay. What asked it is find equilibrium price and quantity when just the only white shirt factory give the supply for the market. So we just deal with the supply function of the white shirt factory. What we know that in the equilibrium, quantity of supply should be equal to quantity of demand. And we know that our quantity of supply function is equal to quantity of supply function of white factory. And I know that this is minus 5 plus p. These are the information that I derived from the question itself. Okay, so uh, we have three different points. Okay, since let's go on to demand graph. Okay, I want to show something to you. We have three different line in. We have line with three different slope in this aggregate demand function. So when we consider for the equilibrium, we should find out that in which line our supply function will be intersect. To do this, you have to equalize supply function for each of this line and find out that for that price level, which line, which intersection is proper. Okay? You have to calculate the equilibrium point for both these three lines, and you have to check that if the price level is okay for that line area. Okay? How to do this? Let's check again. Okay. Start with the first graph. We know that our supply function is minus 5 plus p. And when the demand function is 40 minus 70p divided by 2, find out the price level. If you do this equalization, okay, you will find out that price is equal to 10. But recognize that when the demand equal to this level, when the price level is lower than 5. But we find out the equilibrium price as 10, okay? This is 10. So the supply curve does not intersect with these demand levels. Okay, because when the prices is higher than the 5, we are not have these demand levels. So when the price is 10, this is not our equilibrium. Okay. Let's check for the second line. Okay, we again have the same supply equation, but our demand equation changed now. We have 35 minus 5p divided by 2 as the aggregate demand. Let's check the equalization. If you do this math, you will find out that price is equal to 11.42. Again, check for the price level. We know that our demand function is equal to this amount when prices is between 5 and 10. But since we find out the equilibrium as a 11.4, it is more than the 10, then this level does not satisfy the rule This is not an equilibrium price. Finally, check that for the final demand line. This is our, again, supply equation. We know that 30 minus 2p is our aggregate demand equation. If you equalize them, you will find out that price should be equal to 11.67. Since the demand curve equal this amount when the price is higher than 10, then the equilibrium price that we find out satisfy the rule, then we can argue that this is our equilibrium price. Okay? So we can argue that our supply function will be intersect with this aggregate demand function. So since in the equilibrium, quantity of demand should be equal to quantity of supply, and when we know that prices should be equal to equilibrium price, and this is equal to 11.67, you can plug 11.67 into the supply or demand function. I just plug this information into the supply function. Then minus 5 plus 11.67 should be equal to 60.67. So we find out both the quantity of demand and quantity of supply in the equilibrium. These are equal each other. And we also find out equilibrium price as 11.67. So is that all? Is that all for the C section? Is there any question for this part? So good. Let's go on with the D section. Okay, I need to check what is the question for the D section. I'm sorry, just a minute. For the D part, find the market equilibrium price and quantity when on the Black Short factory can sell Eagle shares. Okay, we are going to do the same calculations. Now our supply function equal to Black Short factory's supply equation. Also find the amount of Eagle shares that will be bought by Metin, Ali and Fayaz. Okay, let's do this now. We are going to do the same thing for the D section. Okay, we know that the supply function equal to minus 4 plus 2p for the Black Short factory. Again, first of all, I equalize this supply function with the aggregate demand function for the 40 minus 7p divided by 2. I found out that price is equal to 8. But what happens when when the price is lower than 5, this function is true, okay? But when the price is 8, this is not true function. So this is not possible that this is equilibrium. This is not an equilibrium. Check for the second one. Again, equalize them. Find out price is at 80.66. Since this is true when the price is higher than 5, okay? These price levels does not break the rule that we find out. Therefore, 8.66 is an equilibrium price for our case. And we know that in the equilibrium, demand should be equal to the quantity of supply. Since the quantity of supply equal to minus 4 plus 2p, I can plug these price amounts 8.66 into the supply equation and find out that in the equilibrium, demand and supply should be equal to 13.35. Let's go on. We find out the equilibrium, but you can also check that is there any second equilibrium or not. We know that this is our supply equation, but for now we have aggregate demand function as a 30 minus 2p. If we do this math, we will find out that price should be equal to 8.5, but this is not to satisfy the rule that we argue price should be higher than the 10 to use this graph, this aggregate demand equation. But this is not the case. This does not satisfy the rule. Then this is again not an equilibrium. What we what we find out, the only equilibrium when the price equal to 8.66 and the equilibrium demand is equal to 13.35. That's all. Is there any question for that? You don't have? Okay. Now we find out the aggregate demand for the shares, but we should also find out the individual demands for this price level. Let's go on with that. Okay, we know that aggregate demand is 13.66 and equilibrium price is equal to 80.66. Since this price level, we do not have the positive demand for the third person. So we should check the demand for the both first and second consumer. We know that the demand function of the first consumer is equal to 10 minus P divided by 2. If we plug this equilibrium price into this equation, I will find out that quantity of first person should be equal to 0.67. If we do the same thing for the second consumer, I know that this is his demand function. If I plug 80.66 into this demand function, I will find out that this is 11 to 12.68. If you plug these two amounts, you will find out that this is equal to 13.66, which is also equal to aggregate demand. So, and this is our solution. It shows that our solution is correct. Is there any question for this part? No? Okay. Let's go on with the second questions. First one is done. Okay. Cleopatra spends all her money on bags and shoes. And we know that her utility function is equal to this amount. We know that her income is equal to $150. And what we know is, we know that price of shoes is equal to 2. And we have a reduction in the price with respect to quantity of bags purchased. When the purchases bag is equal to 1 or is equal to 8 or lower than 8, the price of the bags is equal to $5. If she purchases more than 8 bags, then the price falls to $2 for all subsequent books. For the A section, we need to find out the budget constraint where bag is on the horizontal axis. For the second part, we have to solve the optimal bundle for Cleopatra. And for the C section, we are going to change the utility function and we will show that as a LM function and try to find out the optimal bundle again. Let's start with the A section. Okay. Find out the budget line, first budget line. When the quantity of bag is equal or lower than the 8. We know that price of the shoes equal to 2. So we should multiply price with the quantity of demanded for shoes. And we should sum price of the bags when the quantity of bags lower than 8, which is equal to 5. And we should multiply this amount with the quantity of demanded for bags. If we sum this information, it should be equal to 150 because this is our all income, right? For the second budget line, we have to do some calculations. I'm going to show that how you can do this. Let's start with try to draw the graph. I know that quantity of 8 should be an important point for us, right? Because after the point 8, our demands, our budget line is going to be shift. So there's some kind of connect in this part. So I know that 8 is important. Let's start with the draw first budget line. Recognize that when the quantity of book is equal to 0, then what we only have $2 multiplied by quantity of supply, which is equal to 150. If we find out the quantity of supply, we will show that if we do not have any book, any bags, we can buy maximum 75 shoes. Okay, I find out information from this budget line. Let's check for the point 8. When the quantity of bags is equal to 8, what is the maximum amount of shoes that I can buy? If I plug this 8 into this budget line, if this part is equal to 8, then this part should be 40. 150 minus 40 should be equal to 110. Therefore, maximum amount of shoes that we can buy should be equal to 55. Okay, if you plug 8 into the first budget line, I will find out 55 as the maximum amount of shoes. For the remaining part of the questions, let's try to find out the marginal rate of transfer. I showed that how you can calculate marginal rate of transfer during the recitations. For the second line, we know that price of bags is equal to $2 when the quantity of bags higher than the 8. When this area, I know that the price of bags equal to $2. And I know that the price of shoes is equal to $2 also. Therefore, slope of this curve should be equal to -1. Since this part is 55, this length is 55, since this slope is equal to 1 minus 1, what happened to the length of this part? It should be also equal to 55. Since this length is equal to 55, which part is our budget line intersects with the x-axis? It should be 63. How can I find this? I know that this length is equal to 55 and this amount is equal to, it starts with 8.8. I sum the 8 with the 55 and find out this intersection should be realized when the point 63. Okay? So I easily draw the graph. So you can easily draw the graph. So what about the budget line? I need to find out the second budget line. How can I do this? Okay, what we know that price should be equal to 2 for the shoes and price should be equal to 2 for the bags. And the income again is 150. But we should draw this line when the quantity of bag is higher than the 8. So it means that we are going to draw this line after the amount of 8. Okay, we are going to do this. So try to find out this amount again. When the price of when the amount of shoes is 0, when this part is 0, this intersection should be equal to 63. Okay, when this is 0, then I should intersect with the x-axis on the point 63. Assume that we do not have this part, okay? I try to find out this coefficient. I'm trying to show that how you can find out this coefficient. Since this part equal to 150, 150 minus this coefficient should be equal to 2 multiplied by 63 because this is maximum amount of bags we can buy when we do not have any shoes. Okay, so since 63.2 equal to 126, then 150 minus 126 should be equal to this coefficient, and I find out this coefficient as a 24. I know that it seems a little bit complicated, but first when you find out this point, and when you plug this information into these parts, okay, when you plug 0 for quantity of shoes and 63 for the quantity of bags, you will find out that this intersection, this coefficient should be equal to 24. I'm going to use this information to find out the optimal bundle, so therefore this part is important. Okay, let's go on with the optimal bundle, B section. Is there any question? Okay, let's go on. What we know for the optimal bundle, we know that marginal rate of substitution should be equal to marginal rate of transfer. And what we know that marginal rate of substitution is equal to marginal utility of bags divided by marginal utility of shoes. Obviously, it is a negative version of that. Let's try to find out the marginal utility of bag. We know that if we want to find out a marginal utility of a good, we have to find out the partial derivative of the utility function with respect to that good. If we do this partial derivation if we apply this partial derivation to our utility function, you will find out that it is equal to S divided by B powered by 0.5. Okay, I just take the partial derivative of the utility function. If you do the same thing for the utility of marginal utility of shoes, you will again take the partial derivative of utility function with respect to S, and you will find out that it is equal to B divided by S powered by 0.5, which is exactly the same, a similar thing with the margin utility of back, but just we have a different denominator and denominator and denominator. Okay, how we can find out the marginal rate of substitution? We know that marginal rate of substitution is equal to marginal utility of bag divided by marginal utility of shoes. I find out the marginal utility of bag as this from that part. Okay, this is marginal utility of bag. I know that marginal utility of shoes equal to this amount. Okay, when I do this math, when I divide them to each other, I will find out that marginal rate of substitution equal to negative version of the S divided by B. Okay. I just use the definition of marginal rate of substitution. Let's go with the second part. Try to find out the marginal rate of transfer. Recognize that we have two different marginal rate of transfer. The first one and the second one. Okay, in the first part, I know that the marginal rate of transfer is equal to slope of this line, and since this part, price of bags equal to 5 and price of shoes equal to 2, the marginal rate of transfer is equal to 2.5 for this line. Okay, for the second part, when the quantity is higher than the 8 for the bags, we know that the price of bags is equal to 2. Since the price of shoes equal to 2, then if we divide them each other, we will find out that marginal rate of transfer equals to 1, which is also slope of this line. So we have two different marginal rate of transfer, and we have one Cobb-Douglas utility function, and we don't know that in the which line our utility representation is going to intersect or is going to tangent to our line. Therefore, you have to check the tangency for both of the cases. Let's do this. We need to check where the indifference curve tangents to budget line. Let's start with the first line. If indifference curve tangent to first budget line, what happens? I know that for tangency, marginal rate of substitution should be equal to marginal rate of transfer. Since marginal rate of substitution equal to negative version of the S divided by B, and since the marginal rate of transfer is equal to 2.5 for the first budget line, if I just do this multiplication, I will find out that S should be equal to 2.5B. I do this math, this equalization, and find out this information. Take this as equation 1. And then, to find out the intersection point, tangent point, we need to plug this equation 1 into the first budget line. Okay? I know that this information. If I plug this information into the first budget line, what we know, price of shoes is equal to 2, and the quantity of shoes equal to 2.5 multiplied by quantity of bags plus $5 for bags, for each bags, and quantity of bags is equal to 150. And we know that this is true when the quantity of bags lower than the 8, equal or lower than the 8. This part is important. We are going to use this information as a control point. Let's do this math. If you do this math, you will find out that time B is equal to 150 and therefore B is equal to 15. But recognize that 15 is not lower than the 8. So it is not proper for our rule since the quantity of bag in the equilibrium higher than 8, then B equal to 15 cannot be our optimal bundle. What this information give us? What should we think about this? We need to understand that our indifference curve does not tangent to first budget line because it says that it is going to tangent the budget line when the bags is equal to 15, but recognize that when the bags is equal to 15, we have another budget line. Therefore, this is not optimal bundle. Check for the second budget line. If the indifference curve tangent to second budget line, what happens? Again, marginal rate of substitution should be equal to marginal rate of transfer for the second budget line. We know that marginal rate of substitution is equal to, again, the same amount, but marginal rate of transfer is equal to minus 1, okay? Because we have new budget line. Since we do this, do math, and we will find out that S should be equal to B. Okay? Again, assume now this second equation that we find out. If you plug equation 2 into the second budget line, let's do this. We know that we have this coefficient or this part. And we know that the shoes price of shoes is equal to $2 and amount of shoes should be equal to amount of bags in the equilibrium. I know that from equation 2. I know that price of bags is equal to 2 and we have amount of B and this is equal to 150. This is our second budget line. I just plug equation 2 into this part into the second budget line. And if we do this, if we do math, I will find out that for B equal to 126, if I find out B, leave alone the B, I will find out that the B should be equal to 31.5. If the B is equal to 31.5, what about the amount of shoes? Since we know that from equation 2, S should be equal to B in the equilibrium, then the amount of shoes should be also equal to 31.5. Okay, so recognize that we need to check again for the quantity of bags and check that if it is satisfy our rule for the budget line or not. Recognize that I find out in the equilibrium quantity of bags equal to 31.5, which is higher than the 8, then it is our optimum bundle because when the price is high, when the quantity of amount for the bags higher than the 8, we know that we need to use second budget line and it satisfies our rules. Therefore, this one is our optimum bundle. Okay? Is there any question for these parts? So I'm going to Saad asked something for me. I'm going to read what he said. He said that I applied the concept that in such cases, the indifference curve that is purchased from origin is the one in which we can find the optimum bundle. Isn't that correct too? Um, yeah, for these questions, your idea is true because you are probably you will find out the same thing because the purchase curve. Um, hmm. So, Saad, did you find out the same amount as the optimum bundle? So probably you should find out the same amount because as you can try to draw the indifference curves, you will find out that the furthest indifference curve should be passed from this part because the slope of this line is uh, is lower than the slope of this part, right? But if the case is different, again, let's assume that this slope of this part is higher, lower than the slope of this line. Assume that we have, I don't know how can I draw it, but assume that we have this kind of graph. Okay, this is the first line, and this is this is the second part. Now, for this kind of question, it can be a little bit hard to do the same thing that you do. Okay, so probably if you try to do this calculation, it can be more easier to find out the proper optimum bundle. Okay, your argument is absolutely true, but if the slopes a little bit change, it can be really hard to apply it. Okay, so but you can use this information easily for all the other cases. Okay, let's go on. Okay, what about the C section? It asks us that find optimum bundle with new equation. Let's assume that we have a log transformation for our utility function. We have ln version of our utility function, and it asks us that find out optimum bundle. Again, what you are going to do, you are going to find out the marginal rate of substitution. Okay, if you do this, you are going to find out the solution easily. Again, marginal rate of substitution is equal to marginal utility of B divided by marginal utility of S, negative version of this. But you know that if you again take the partial derivative of utility with respect to B, you will find out that this amount equal to 0.5 divided by B. Okay? If you apply partial derivative for the ln utility function, you will find out this information. What about the shoes? Again, partial derivative of shoes equal to 0.5 divided by S. I just take the partial derivative. I just use the partial derivation rule for the ln function. And again, try to find out marginal rate of substitution. 0.5 divided by B divided by 0.5 divided by s. If you do this, if you divide these both of them, you will find out that it is equal to s divided by b. So what we recognize in this part, again, we find out s divided b as a marginal rate of substitution. What about the first part? Okay, in the B section, we also find out the marginal rate of substitution is equal to S divided by B. Since the marginal rate of substitutions are exactly the same in the A and B section of the question, we can argue that our optimum bundle does not change, because again, what you need to do to find out the optimal bundle, you need to use this marginal rate of substitution and equalize the marginal rate of transfer. But since the marginal rate of substitution is equal to A and B section of the questions, it doesn't change anything for our calculations. We can still argue that our optimum bundle will be 31.5 as an S and 31.5 as a B. So that's all. You need to just calculate the marginal rate of substitution, and you should argue that this amount is equal to first A and B section of the question. Okay? So that's all. Is that clear? I guess this is the simple one. Okay, let's go on with the third questions. Okay, for the A section, I think that it is a little bit harder one. Suppose a tax on beans of $0.2 per can. As a result of tax, the equilibrium price increases from 0.4 to 0.5. What fraction of the incidence tax burden falls on consumers and on firms? Suppose the supply elasticity is 0.4. What must the demand elasticity be? Okay. I checked this question with the professor, and he said me to that you need to use a definition to solve these questions. Okay, and I'm not sure that you cover this from the lessons, but you need to use this equation to apply this kind of text and elasticity questions. Let's start to check what are the part of this equation. Okay, let's check. This is delta P. It refers to price change with respect to burden. This new, okay, this part, this shows the supply elasticity, which is equal to 0.4 in our case. This part is the demand elasticity. We refer demand elasticity with epsilon. And this is the delta T, and it shows the change of the tax burden. It is not the tax burden, but the change for the tax amount. Let's check for our case. Let's use these information, these equation to for our case. We know that price change is 0.1, right? Because what it says in the question, it says that in the equilibrium, price increased by 0.1. We know that supply elasticity is 0.4. We do not know the demand elasticity. I just leave as an epsilon for demand elasticity. And we know that delta T, tax burden, equal to 0.2, right? I'm going to check one more time. Yes, it is 0.2. So, let's take 0.2. Let's divide both sides to the 0.2. What happens? We find out that 1 divided by 2 should be equal to 0.4 divided by 0.4 minus epsilon. Let's again do this cross multiplication, okay? Then we will find out that 0.4 minus epsilon should be equal to 0.8. If we leave alone epsilon, we will find out that epsilon should be equal to negative 0.4. This is our demand elasticity, okay? It means that when the price increase 1%, our demand will be, the quantity of demand will be decreased by 0.4. So what about the tax burden? I mean, how the consumers and the suppliers will share the tax burden? Recognize that the government is going to take 0.2 from the supplier side. But recognize that consumers now should be pay extra amount of 0.1 since the price change as 0.1. Then we can argue that consumers are going to pay 0.1 more to buy that good. Therefore, they are going to share the burden of the tax equally. I mean, for 0.1, consumers are going to willing to pay. For the remaining part, suppliers are going to willing to pay. Okay? So we can argue that they are going to share the burden equally. Is it okay for everyone? Okay. Let's go on with the B section. What it asks for the B section, check one more time. If the demand function for orange juice is expressed as quantity of demand equal to 1000 minus 40p, where Q is the quantity in gallons and P is price. For what values of prices demand for orange juice is inelastic? You need to think about inelasticity. When the demand is inelastic, you need to know that information from your classes. If the demand elasticity is higher than the -1, we can argue that this demand is inelastic. It means that even if the price change, then our demand is not going to change. So what about the elasticity formula? We know that we have this partial derivation in our inelasticity formula, and we have P divided by Q. We need to multiply this amount to find out the elasticity, demand elasticity. And we know that if you find out the inelasticity, this elasticity should be higher than the -1. Okay? Again, how can we find out delta Q divided by delta P? We need to take the partial derivative of demand equation with respect to price. Check for that. Okay. Take the partial derivative of this equation with respect to P. Since we do not have any related part with P, we are going to take 0 from there. And we are going to take -400 from this part as a partial derivation. Okay. Then we can argue that this amount, this delta Q divided by delta P, is equal to -400. In the above section, we have P. What about the quantity? We know that this quantity is equal to 1000 minus 400 P. Since we need to find out some equalities, some information with respect to price level, we just take this information, take this demand equation, and plug this equation into this elasticity formula. Okay, you need to do this to find out the price easily. Okay. If you do this math, you will find out that -400p is higher than the 400p minus 1000. And if you leave alone the p, you will find out that to make the to make the demand inelastic, we need to find out that price should be lower than the 5 divided by 4. Okay? I just write the elasticity formula, and I just use the information that I know from the classes that demand is inelastic when the elasticity is higher than the -1. And I do this math, and I plug the demand equation rather than the quantity of demanded, and I find out that price should be lower than the 5 divided by 4. So is it clear enough? There isn't any question from you, so I'm going on with the C section. Please, if you have, please ask me. Let's think about the C section. Suppose demand and supply for a good is given by quantity of demand is equal to 150 minus 2p, and quantity of supply 50 plus 23p. The government imposes a price floor of $3. What is quantity bought and sold in the market? Okay, what we need to do, you very well know these kind of questions from the recitations. We know that in the equilibrium, quantity of supply should be equal to quantity of demand. Okay, 50 plus 23p is our quantity of supply, and 150 minus 2p is our quantity of demand. If we equalize them, then we will find out that price should be equal to 4 in the equilibrium. But what we know that government imposes price floor which is equal to 3. It means that any supplier can sell their goods which is lower than the 3. Okay? This is the floor. But what you need to do as a second step, you need to compare this price level with the equilibrium prices. Since the equilibrium price is greater than the government imposed price floor, then we can argue that it doesn't change equilibrium level in the market. Okay? Because this imposed price is lower than the equilibrium price. It does not change our equilibrium. It doesn't affect anything. So we can argue that in the equilibrium, our price should be equal to 4. And if you plug this 4 into one of the supply or demand equation, let's assume that we plug this price level into the demand equation. This part should be equal to -8. 150 minus 8 should be equal to 142. This is our quantity demanded in the equilibrium. So this is really simple one. We did the same things during the recitations. Is there any question for this part, for C section? I think you're all fine. Let's go on with the D part. In the D section, Leonardo is indifferent between lahmacun and pizza. Lahmacun sells for $2 and pizza sells for $1. Assuming that Leonardo has a budget of $10, how will he spend it? Explain your answer by drawing Leonardo's budget line and indifference curves. Let's check for that. Okay, how we can draw the indifference curves? We did this similar example during the last recitation. Since the Leonardo indifferent between lahmacun and pizza, we can argue that the amount of goods, pizza or lahmacun, that he is going to consume does not differently change his utility. It means that the marginal utility of both these goods are equal to each other. Then we know that we can understand that these goods are perfect substitutes. Therefore, we need to draw this indifference curve as a straight line. We understand this from the part that Leonardo is indifferent from lahmacun and pizza. Okay? Therefore, this should be straight line. What about the slope of this curve? You know that they are indifferent. It means that marginal rate of substitution should be equal to -1 because there isn't any change between marginal utility of L and P, since if you try to find out the marginal rate of substitution, which is equal to marginal utility of pizza divided by marginal utility of lahmacun, then you will divide exactly the same amount to each other and you will find out the one as a conclusion. Therefore, this is should be equal to slope. The slope of this curve should be equal to 1 -1. What about the budget line? What we know of that? Let's check again the questions. I'm sorry. What we know that we have $10 as a budget, and if we do not buy any pizza, if just use this amount to buy the just lahmacun, then since the price of lahmacun is equal to $2, we can buy the maximum amount of lahmacun that we can buy is equal to 5, right? And uh, if we spend this amount just buy for the pizza, do not buy any lahmacun, the maximum amount of pizza that we can buy should be equal to 10 because the price of pizza is equal to 1. So we can argue that our intersection point will be 5 for lahmacun and 10 for pizza. So I just draw the budget line from the information. So what should do as a next? We are trying to find out the optimum bundle, right? We are trying to find out that intersection between indifference curve and the budget line, and this part should be maximized. Our indifference should be maximum level of the indifference curve because it should be give us maximum utility. Try to draw two different lines. I showed these kind of things during the last recitation. You can draw a indifference curve from this part, from this corner. It is going to intersect this level at point 5, right? I'm not writing it now, but this point should be 5. If you draw the indifference curve from this part, from this left corner, you will find out that this indifference curve is going to intersect at y-axis on the level 10. Okay, this curve, now you should compare this curve, this indifference curve, with this one. Which one shows the highest utility? We know that both of them are feasible. One of them shows this part, one of them shows this part. Both of them are feasible. It is in the budget constraint. But which curve give higher utility? Show represent higher utility. We can argue that more is better. Therefore, this indifference curve is show higher utility level. It is far from this point 0. Okay. Therefore, we can argue that our optimal bundle will be this part. Then we will use our all money to buy just pizza, and it is the amount of maximum pizza is equal to 10. This is our optimum bundle when the pizza is equal to 10 and lahmacun is equal to 0. I guess we are done. If you have any question, please do not hesitate to ask. That's all for today. Thank you for listening. Uh, so that's all. You are still have a homework uh, for that, I guess. Some of the people ask me about that, but it's okay. So you need to solve these again, okay? So ask me that what will the results be released? I'm not sure about this, but maybe tomorrow you are going to learn that. Not so far, but I'm not sure again. Okay? Uh, I'm not going to send the questions. I'm going to probably recorded version, but I need to check again. I need to ask again to professor for that. Okay, that's all. Goodbye.